Okay, this is a tutorial about Spanning Tree Protocol, or STP. Now, STP is a layer 2 protocol that helps networks to avoid switching loops or frames looping endlessly on the network, right? This can cause a layer 2, what's called a broadcast storm, where frames keep duplicating across the network, expanding until no traffic can be sent on the network because there's just endless frames and packets just traveling across the network, just kind of exponentially multiplying until no data can get through. Right? So I've got a network that I set up here in Packet Tracer, and what I've done is I've built in the type of situation where STP is needed. All right. Now, this type of situation being a network where you have redundancy or multiple switches, right? Redundant paths that could create a looping scenario. So, for instance, this PC here, if he wants to send to this PC on the right, on the far right, he can go this way, right? From here to here to here, or he could go this way from here to here to here, and so forth, right? So there's multiple paths or redundant backup switches. So if this switch goes down, let's say, you've got redundancy. So this switch goes down, and there's another path that the packets could travel to get to the destination over here, right? So it's in a network like this where STP is really needed, because although redundancy is typically a good thing, you want fault tolerance, you want to have backup switches and multiple paths, it can cause what's called switching loops. And that can cause layer 2 broadcast storms, which could just shut down the network, right? So what I've done here in this network, I've shut off the spanning tree protocol. So I put in this command right here on each switch on the network, right? And now you can see the result is we've got all green lights. All interfaces are in forwarding mode, and there's no STP to stop those switching loops. So every port that's activated, right, is in a forwarding mode. Now compare that to this scenario where I have STP running, and in this scenario you can see that every switch where there's a redundant path, right? We can go this way or that way. Notice one of them is in a blocking state. So this port going this way is blocking. This one going this way is not blocking. And the same thing here, not blocking, right? And then the orange indicates a blocking scenario, right? And STP has managed to see the redundant paths, right? Figure out what is the fastest path to get from, let's say, point A over here, right? And I'll just put that right here, point A, right? To point, let's say, the last PC, point D, right? So this is D, this is A. So it's figured out the fastest path to get from point A to point D. And what did this? Well, the spanning tree protocol did this. Spanning tree protocol uses the spanning tree algorithm, or STA, right, to figure out the fastest paths across the network based on a metric of cost, right? So anyway, you can see here that spanning tree protocol has shut down some of these ports to help prevent switching loops or broadcast storms. Now let's see if we can get an example of this working, right? Let's see if we can essentially get an example of this working. Well, let's try it out first of all with the network that has spanning tree protocol off. So what we'll do is I'll minimize this. We'll go over here, and what we want to do is set up a scenario where this PC over here on the left is going to send out a broadcast, right? And that broadcast is going to travel on the network. You're going to see what a network does when spanning tree protocol is not enabled. Now, by default, if this PC sends a broadcast to this switch right here, switch 0, will forward it out of all activated ports, right, except for the one it came in on. So this switch right here will forward that frame, that layer 2 frame, out of this port, right, and then out of this port. And what will happen is that it'll be broadcast out of these 2 ports to the next 2 switches, and then those 2 switches will broadcast out of every port that's active except for the one it came in on, and what will happen is packets will start to go everywhere. Now let's try this out. Now for this broadcast to happen, to simulate this, what we'll do is we'll ping from this PC to this PC on the far right. Now typically a ping would not create a broadcast if the PC on the left knows the MAC address of where it's delivering the frame to, right? In other words, to deliver a frame or a packet on the local area network, the PC delivers it to a MAC address, and I've got the MAC address listed right here on the PC, right? And if it doesn't have this MAC address or IP address to MAC address listing in its ARP cache, this PC will have to send out an ARP broadcast to find the MAC address of the device it wants to deliver the frame to. So let's take a look first of all at the ARP cache on this PC on the far left. You can see here I've done an ARP-A 3 times here, and you can see that it has no knowledge of the IP address to MAC address or the internet address to physical address, that's IP to MAC, so it does not know where this PC is. So to deliver a ping from here to here, it's first going to have to send out an ARP broadcast. So what we'll do is, so here we go, let's attempt to send a ping to this machine back and see if it fails with spanning tree protocol off with a large network with so many switches and so many potential loops that could happen to create a broadcast storm. So once again, we'll open this up. Now I tried to do this in simulation mode and I crashed Packet Tracer probably because there's so many switches, and with spanning tree off it just got overwhelmed and I crashed it in the simulation mode. So I'm just going to use real-time mode and see what happens. It might crash the system, we'll see. So once again, we'll do an ARP-A. You see that he's got nothing in his ARP cache, so it's going to have to send a broadcast from this PC out to find the MAC address of this PC before it can send the ping. So let's see what happens. So ping 192.168.1.100.102.103. All right, 103. Enter. So there goes the ping, and we're going to see what happens here. Now, request timed out. All right, so we got a timeout, timeout, timeout. It's not going through. All right, this should be going through. All of these switches, right, are on the same VLAN, VLAN 1. And they all have 192.168.1 addresses. How come this PC cannot ping this PC? Well, the answer will be maybe a broadcast storm, right? Or layer 2 loop, or both. Spanning tree protocol is off, so it's not working. Let's try it on the network that has spanning tree. Okay, so this network has spanning tree protocol activated. You can see the orange lights indicating ports that are put into blocking mode, right? We're going to try to ping from here to here. We'll run the same test. All right, go to desktop, command prompt. We'll do an ARP-A. Notice ARP cache is empty, right? So it doesn't know how to ping or how to deliver a packet or frame to this MAC address. So it's going to have to broadcast first. So let's see if it can negotiate the broadcast with spanning tree protocol and then deliver the ICMP ping and then receive one. So we'll do ping 192.168.1.103 and hit enter, and there's instant reply, right? So you can see that the network that has spanning tree protocol activated is able to ping across the network successfully, and the network that doesn't was not able to. And in the network that doesn't have it enabled, this one, when I tried to do it in simulation mode, I got a huge problem and did not work at all. So it crashed the whole system having this many switches. So simulation mode didn't work at all. A quick note on how I built this network in Packet Tracer. I dragged out the switches, and then what I did was I shut down all of the ports on the switches to start with, and then I just activated the ports that I needed. So I've got access ports going to these PCs here, right? So these are an access port, an access port, an access port, an access port right here. And then in between the switches, all of the links are trunks. Going from switch to switch. They're all trunk ports. And then the whole network is just VLAN 1 anyway, so it's just it's all VLAN 1. And if you would like to download this packet tracer so that you could follow along and try this out for yourself, you can find my 2 packet tracer files. This one, which has spanning tree protocol off on all of the switches. So I went in and put in this command on all the switches to turn off spanning tree protocol. And then the other one, which is this one, which has spanning tree protocol activated, just go to my website at danscourses.com, go to the CCNA3 area, and then once you're in the CCNA3 area, look for the page on STP, spanning tree protocol.